this video, I'm going to assemble this TU8100 stereo amplifier kit. It's based on the PCL86, which is a single tube amplifier. It's actually a combination triode and tetrode that was made popular by the Mullard Corporation in the late, I think it was the late 1950s. It was used as the sound output for television. So in this video, we're going to build this amplifier kit, and I'm shooting this in 4K, so we'll get a real good close look at the details of this fine unit. Well, the first thing I'm going to do is I'm going to open up the box, and we'll make sure that everything is complete and that there's nothing missing. It's a cool night out tonight, so I've actually got the heater going in the shop here. I don't intend to have this running the whole time, so you'll be able to hear what I have to say. It's just right now I've got the heat on because it is kind of cold in here tonight. It's the coldest night we've had all year so far. So first we get the box open, we can unpack all of the materials in here. There's a manual. I hope it's in more than Japanese. The manual's all in Japanese. Are we going to have any English in here at all? Holy smoke. It's a kit from Japan, and the assembly instructions all appear to be in Japanese. That may make for an interesting build. Yeah, I don't see any English in here at all. Hopefully they've got everything well labeled, because this could be a fun build if there's no English instructions. So I'm about to have lots of fun putting this kit together because, well, I don't read Japanese. Fortunately, Google Translate does. So I'm just going to read what the translation is, because it's kind of funny if you read how this technology translates. It says the Elekit PCL86 single stereo power amplifier kit TU8100 assembly instructions. Compact unnotification using the composite blast PCL86 for audio. In addition to the usual pin RCA jack line in, it has two input terminals of high sensitivity setting stereo mini jack, which can connect directly to portable B pusher. The power supply uses a worldwide AC adapter, and the inverter circuit, which was AR on the main body, generates high voltage of vacuum, and there is no power ham at all. It is also possible to use an ECL86 6GW8 tube, which is a different tube, with different heater voltage by switching on board. Contents: 1. Parts list. 2. Assembly the board. 3. Assembling the main body. 46. Assembling the tube protector. 5. Notes on use and operation. Checking 64. Operation check 127. Troubleshooting. Thinking it is funny. 12.8. Connection example 13.9. These must be the page numbers. Enjoying the attractiveness of vacuum tubes. Technical data, and here we go. Electric Doctor Repair Parts Guide 16/1. Precautions on assembling and precautions before assembly. I'm not making this up, okay? Before assembly, be sure to read ML after standing out 8 in Lee, who regularly read the explanatory manual. Please do assembly and operation tests properly according to unpacking. Also, please keep this explanation for ease to see at any time. Do not work at a place where there is a risk of water being applied to parts, you think? Such as near Waterfield, ECAT, fire, feeling gone cause, T-vases on work desks, parts, and nearby, E-cup, E-goods. Do not place containers on or the lake of water, etc. If the contents spill, etc., it may cause electric shock. You think? Assembly and storage. Oh boy. Keep out of reach of young children. Also, bag containing items 19. Co that come out at the time of assembly should be separated according to a method prescribed in each municipality. What's the municipality got to do with it? Please handle. Please also twist to a place out of reach of infant. If you do not follow it, you are injured. It may cause environmental damage. Please do enough to use the rainbow. Be especially careful of accidents due to knives, such as nippers and cutter knives. Do not eat in places with small children. Do not eat in places with small children. Okay. I love it. I'm getting a kick out of the translation here, but I'm going to look at this manual and figure out what parts go where, and then we'll start making our way through putting this scene together. Seriously though, if you want to read this, it's like, well, like here, like, please do enough to use the rainbow. Please, especially careful of accidents due to knives such as nippers and cutters. Do not eat in places with small children. There are dangerous situations such as touching a piece or putting parts or plastic bags in a bowl. Parts may be using small ones, sharp shapes made of metal or glass due to the necessity of the dragon. Oh boy. So careful not to put small children in their mouths or injuries. Please, all children, please consult with your doctor if you ingest. Also, please throw, this is the safety, right? But I'm looking at the translation on here, and some of the phrasing is just absolutely hilarious. But I think we'll be able to struggle through this thing and get it put together, and hopefully it won't take that long. So basically, what this is telling me here is like for example, the .33. This translates to orange, silver, gold, right? And then this one here, where are we here? 27 ohms. I'm just looking at here, 120. It reads it as 270, but it's really 27. Anyway, we know our color code, so I don't need to translate all this here. Our components are labeled. What I'm more interested in here on this unit is the actual locations of the parts. And fortunately, it has our locations, like R19 is a 2.2K, R20 is a 2.2, R25 is a 10K. So I think I can figure out the layout here, just because it does list the components here, and let's see if it's got an IC in it. That would be the input jack. It's got LED. Anyway, it does list the components. Tells me this is an FET. It's a K4017, and there's a couple of ICs, a 78L05 and a 16F1827. So it does list the parts, and I think my circuit board here, I was looking at the board, and this does appear to be quite well silkscreen. So I think we'll be able to figure out what parts go where on this and get this kit together. Of course, the first thing I'll do is I'm just going to separate the boards. All the pieces, all the separate boards just snap free. Now the boards are all separated. They've been pre-cut and pre-scored. So now I've got the boards ready. The next thing I'll do is I'll start sorting out my parts, and we'll start in each of the sections. I'll mount these resistors here. I'll mount all these resistors. Then I'm going to do everything. We got a little check box so we can check each component off as it's being installed. So I've got a bag full of parts here. So here's all our parts. Let's get the parts open, and we can start mounting parts. This is certainly not going to be a project that's going to be finished tonight. This is going to be a project that I'm probably going to be working on for the next probably for the next couple days anyway. But I think we'll put some priority on getting this thing together. Going to wait for my iron to warm up here, and then we'll start mounting some of the resistors. Now, anytime you build a kit, it's a good idea to lay out all of your parts so that everything is organized. So I've set out my separate table here, and I'm going to lay the parts out. All the main parts are all contained each in individual small bags. So that allows you to work on each stage one step at a time. So we'll start out with the resistors, and I'm going to follow the instructions and mount the components on the boards and then check them off as I'm mounting them. And that way everything is going to be done in sequence, and that's the proper way to build a kit. I built a lot of Heath kits when I was much younger, and the Heath kit were very well designed kits. The manuals were exceptionally well written. This manual here, well, again, I can't really tell because it's in Japanese, but we're going to have to figure out what we're doing as we're going through there. But first we'll start by mounting the resistors in section number 1. So the first board we're going to assemble here, I can read that part, unit 1. So here's unit number 1. We're going to start with this board. I'm going to take the other boards that are for the other components, and I'm going to put them in a box with the rest of the parts, the loose parts anyway. That way I don't have to worry about losing any parts. And oh yeah, here's this IC. I better not lose that. I'll put that back in the box as well. That way I don't have to worry about losing any parts. And I'm only going to have on the bench here, clean up these empty bags now, I'm actually only going to have the parts that I'm actually working on each unit on the bench as I'm working on them, so that I don't lose any parts and everything will get checked off as I'm doing it. So the first part I'm going to mount is R19. It's a 2.2 K ohm, and it is right there. So I'm going to mount this resistor down to the board, solder it in place, and then we'll check that one off. And we're going to do each one of these parts one at a time. So there's R19. I'm going to solder it down, and then we'll check it off. Hopefully I've got enough solder here. I'm getting kind of low. But we're going to take our time and we're going to do each component one at a time. So I've mounted the camera now on a very close tripod. That's one of the nice things about this particular camera that I got, and that's one of the reasons I got this camera, was because it has a very wide lens, so I can get in really close and I can have the camera only, mere inches from my workstation and work surface. I can actually put the camera right on the bench, and it just makes it, for I think, a little easier for you guys to see rather than over my shoulder. It's like almost over top of me now. So we're going to mount the next resistor, which is R25. It's a 10 K ohm resistor, and R25 goes right there on the board. So let's mount R25. A 10K is a brown, black, orange, in case anybody's not following along. I should put up the resistor color charts for those of you that aren't aware of what they are. Next is R26, which is also a 10 K ohm resistor, and R26, I just have to find it on the board here. It's right next to R25, which is right there. So we'll bend our leads. Sorry about the light reflecting there, but I need the assistance of the magnifier to see exactly what I'm doing here. Make sure that I'm not bridging anything. We'll check that one off. The next one's R27, which is another 2.2 K ohm. So go back and get my 2.2s out of the bag here. Got a whole bag full of them here. So R27 is located right down here, right next to R25. R28 is another 2.2k ohm resistor. So we get another 2.2, and R28 is going to be probably right beside this one. Yes, it is. It's right beside it, right there. And then the next one's R29. This is also a 2.2, as is R30. So 29 and 30 are these two here. I might as well mount them both at the same time. So I get two 2.2k resistors out, and we'll put them both down at the same time. So we'll check off those two. And then we have a couple 33 k ohm resistors to put down for R31 and R32. R31 and R32 are located, there's R31 there and R32, and they are 33k. So let's find our 33k resistors here. 33k resistors are orange, orange, orange. I wrote down the color chart here in case you guys don't know. It's black is 0, brown is 1, red 2, orange is 3, yellow is 4, green 5, blue 6, violet 7, gray 8, and white is 9. And the phrase that we always used to use, the cleaned up phrase, because there was some raunchy phrases out there, but we used to remember when I was taught in school, bad boys race our young girls, but violet generally wins, was the way, that was the phrase, right? Bad boys race our young girls, but violet generally wins. For black, brown, red, orange, yellow, green, blue, violet, gray, and white. Those are your color codes for resistors and capacitors and other electronic components. So we've got those ones down. We're going to mount the 33k resistors now in spots 31 and 32. Spots 31 and 32 I have to find here. There they go. Slot 31 and 2 is right there. So let's mount those two resistors down, and we're well on our way to assembling this little tube amplifier. And I'm excited. I can't wait to hear this thing work. I've heard these kits before. Before purchasing this kit, they had one on display at the electronic component shop that sells them locally. They're imported here into Vancouver by Lee's Electronics in Vancouver, and you can buy them on his website. And I'm not being paid by anybody to do this. I did not receive this kit to do any type of endorsement. I purchased this kit. It cost me $355, which is the retail price of the kit. So this is a personal purchase. I like building kits, and I like tube amplifiers. So no one's paying me to build this. No one's paying me to promote this. And any revenue I make from people watching this video on YouTube would really be appreciated, because I really want to pay for this thing. But anyway, this is my own little project to do. I just saw it there. They actually have a bigger one as well, which I would have loved to have bought the bigger one, but it was stupid. It was like $1,000, and it was 8 watts per channel. This one is 2 watts, so it's very low power. It's a single-ended tube amp, so it's a class A is what it is, right? It's so the sound quality off this thing is going to be as good as you're going to get off a tube amp. And all these class A amplifiers, they are very, very clean. There's no, because it's not a push-pull design, it's a single-ended output. The power output is low, but the sound quality is very good off them. And anybody who's old enough to remember the old FM radios and stuff, and the tube that is used in this is one that actually was used in a TV receiver, in the sound system on TV receivers. But anybody who's old enough to remember the old tube radios and how great they sounded, like old record players and stuff, And I'm thinking back in the days when they used the 50C5 was the amplifier tube that was very, very common back then, like the old 5-tube radios and the 2-tube record player. The first stereo record player I got when I was about, I'm going to say, I was probably maybe 6 years old, and my dad got me this this record player. I think he got it from one of the captain of one of the ships that came over. My dad worked on the docks, so they had the Japanese ships were coming over to pick up coal here in BC to take it back for the power plant and for the steel industry over in Japan. And they used to always bring all kinds of the coolest things, like the Japanese electronic gadgets that we never saw here in Canada. And I remember getting this record player, and it was a really cool thing. It was the first stereo record player that I actually had. Prior to that, everything we had was mono. And I wish I still had this thing, but it was really, I mean, it was typical of electronics back in the late 60s. We used to always say, oh, it's from Japan, it's junk, right? That's the way we used to view the Japanese stuff, is it was cheap stuff. And this looked really cheap. It was plastic, and it wasn't the width of a record. It was only, it was like 7 inches across. You could put a 45, it had a lid that closed down, and you could put a 45 RPM record on it and close the lid after you started it playing, and it had speakers on either side. It was just a plastic box. It had a volume control and a tone control and a tone arm. If you played an LP, you had to flip the top open, and the actual record stuck out beyond the sides of it, because it wasn't 12 inches across. It was 8 inches across, and so the record would actually stick out on both sides. But this thing sounded pretty cool, and of course I took it apart, and I'm sure I wrecked it. But it had two tubes in it, and they were 50C5s, no transformer. We're talking straight AC power. And the filaments were wired in series, and it just had two 50C5s, which was 100 volts, right? And it was rated at 100 volts input. Of course, we ran it at 120, and we didn't know, right? It was rated 100 volts input, and it used I believe it used a DC motor to run the turntable. It wasn't an AC synchronous motor. It had a little power supply in it, and it used a little, like a tape recorder motor for to spin the record. But the amplifier was designed for 100 volts, 50 or 60 hertz, and used a DC motor. And I used that thing, and of course, your tubes, instead of getting 50 volts each, they're now getting 60 volts each for the filaments, because 120 volts was designed for the Japanese market. They have AC 100 volts, and we're using it here at 120. So you can imagine that, yeah, the tubes didn't last very long. I was always changing those tubes because I'd burn them out. They were over voltage. I didn't know. I mean, I was just a kid, right? I didn't know. All I knew was that the thing would stop working, and I'd open it up, and the tubes weren't lit up, and I'd go and buy 2 new tubes, and it would work. But it sounded phenomenal. Just a single-ended output. It was really cool sounding. So I think we'll get probably the same type of sound quality off of this thing, especially if we get some half-decent speakers. Okay, moving on to R33 and 34. These are 0.33 ohms. So let me go and find the 0.33 ohm resistors. So R33 and 34, 0.33 ohms. The color code for those, I don't know if you can see that or not, probably too close, is orange, orange, silver, because our multiplier band works the same way as our main color code. So for like black is a 0, and brown would be a 1, like times 10, and orange would be times 100, etc. So for example, if you had a black or brown, black, black, that's 10 ohms, because you have 1, 0, and no multiplier. If you have orange, orange, black, that would be 33 ohms. The gold band means divide by 10, and the silver band means divide by 100. So if you had an orange, orange, gold, that would be a 3.3 ohms, and in this case, an orange, orange, silver is a 0.33. So let's mount R33 and R34. We'll find them on the board here. R33 and 34 go right here and here. Here's R33 and R34. And delete slightly to hold them in place. And, of course, check off R33 and R34. Now we have two 10 ohm resistors, so let me find the 10 ohm. Sorry, I misread, that is 10K ohm, not 10 ohms. So that's going to be brown, black, orange. And I have a bag full of them here. So we get the two 10K ohm out here. $35 and $36, I believe. Those are the two there. The silk screening has come off a bit, but that's definitely 36. I think that's 35. 35, 36, 37, and 38 are right there. $37 and 38 are 2.2 K resistors. Some more 2.2s, which are the red, red, and red. Because we have 2 and 2 plus 2 zeros, which is the third band. The fourth band is the tolerance, which in this case is a gold band. And I found 36 and 37 went, or 37 and 38 go right here, these two. Now we have R39, which is 470 K ohms. Anybody want to guess what the color code for that is? For 470? It's going to be yellow, violet, and yellow. Because yellow is 4, violet is 7, and we need 4 zeros. So 470K for R39. And now I have to find R39. And there it is, all right there. At least the board is silk screened. The most difficult project I ever built, and I wish I still had it. I'm still mad that it got stolen. I've talked about this before, but when I was in high school, I built a black and white television camera. And it was a kit form as well, but the board was not silk screened or anything. So I had to work off of a paper overlay that showed where all the parts were, because basically the board that I got was it was an etched board, but it was not drilled, and it was just a copper board. There was no mask on it. And I had to drill all the holes, and nothing was labeled, so I had to look at a paper wiring diagram to figure out where all the parts were. So this is pretty easy compared to the first one I built. And that camera was by a company called ATube Research out of California, and it actually worked. It actually worked, and it worked quite well considering what it was. Unfortunately, somebody wanted it more than me, and they snuck over in the middle of the night and detached it from the house and took it away. Okay, another two more resistors, 40 and 40, R40 and R42. They're 2.2K, so let's go back to our 2.2 bag and grab two more of those. We're down to the last four of the 2.2K resistors. So this is 40 and 42. Just looking for where they go. 40 and 42 go right down here on the edge of the board next to this IC. I wonder what the IC is for. I wonder if it's a preamp or whether it's part of the inverter for the tube. I don't know at this point. I haven't looked to see what the number of the IC is. Part 2 is mounting 6 diodes, which I have 6 diodes here. So let's mount the 6 diodes for part number 2. Diode is a polarized device. It only goes in one way. It's the band side is the cathode. A little picture here shows you that, and it's designated by the line. The anode is the arrow. So we're going to mount D1 through D6, and they all go right here. 1, 2, 3, 4, 5, and the 6th one over here. So our band goes against the side with the line on all of them. So here's our 2 FETs. They go onto the board here, and it shows that the leads are going to be bent at a right angle so that the heatsink can be soldered down to the board itself. So I'm just looking for my needle nose, my fine needle nose, to bend the leads here. I know I have a small pair of them here somewhere, so that the transistor, the field effect transistor, can be mounted on the board like that. And we'll do the same for the other one. Mount the 2 FETs down. I'm going to solder the tabs at the back first, and then go and solder the actual leads down. This is just to hold them in place on the board. This is so that we have good heat transfer onto the circuit board itself. And then we can solder in the 3 pins for each of the FETs. There we go. The 2 FETs are FET1 and 2 are done. That completes section number 3. Move on to section number 4. Section number 4 is 4 capacitors, C16, 17, 18, and 21, and they're all 4 of them are 0.1 microfarad ceramics. And these parts, they will have the marking 104 on them. They go into C16, 17, 18, and 21 on the board here. So 16, 17, 18 are down here. I was looking for 21. 16, 17, 18, and 21. Where's 21? And 21's over here. So here's our 4 caps. So we'll start with number 21. Now these caps are not polarized, I don't think. No, these ones are not. These are not polarized, so it doesn't matter what way these ones go in. But some are. The electrolytics are polarized. You put them in backwards and you're going to have big problems. Okay, that's part 4 is done. I may finish this whole page just for for this one video, and then we'll move on to the next page for the next one. I got 2 more caps to mount here, C7 and C8. These are 2200 picofarads. They'll have a 222 listing on them, and that's these 2 yellow ones right here. So we'll just pop them out of the bag and mount those. There's C7 right here and C8, and these are also non-polarized, so we can put them in any direction. So that's those 2. And now we have ferrite beads, which are these things here, which are just a little, like a little choke. There's 3 of them. And basically all they are is just a little, they're just a little ferrite, whoops, don't want to lose that. They're just a little ferrite core with a wire that goes through it, and they basically they act as a choke coil. An inductor, basically. FB2 goes down over here. And what these are used for is decoupling, to remove any noise and so forth from the circuit. They'll take out high frequency noise. Okay, there's the 3 ferrite bead chokes, basically. And we'll just bend the pins over and solder those down. So that's the 3 ferrite beads. It completes part 6. Part 7 is mounting the IC. And the IC1 and 2, and then there's the jack, and then that'll be the last of the part. So let's get the 2 ICs to mount those. The IC2 is a 78L005. There it is. It's a 3-terminal regulator, and it goes into the board right there. It's a 5-volt regulator. The other IC is a 16F1827. That's a PIC. And it goes, obviously, there's only one place that it goes on the circuit board. It goes right there. We have a notch to show us where pin number 1 is. Pull the PIC out of its. They didn't even give me a socket on this thing. It's just directly soldered down to the board. Okay, there's our IC mounted. We'll just solder that down. And then the last component I'm going to mount is the jack. That will do it for this video, and then we'll pick up the next one as we proceed. Okay, that's the 2 ICs are mounted. Last thing we're going to mount is the audio jack. Just got to find it. It's in this bag. This is the 3.5mm plug. Jack number 3. Jack 3 goes right here onto the board, and it is a surface mount type jack. So we just line up the little pins on the bottom and tack it down. And that's it. That is the first page. First 8 parts, first 8 components that go onto this unit have now been mounted. And we'll catch you in part 2 as we continue the construction of my 2 watt per channel vacuum tube amp. Thanks for watching. We'll catch you in the next one.